Hello, and thanks for joining me. Well, today we're going to build a horizontal boring machine. These things sell for about $900 to $1,400 if you had to go out and buy one. And I built this one for about $100. Actually, considerably less, but I had a lot of the parts. Now, that's not counting the motor. The motor is a 1/4 horsepower, and they're fairly abundant used. Unless you're looking for one, then you can't find one. But anyway, it's a 1/4 horsepower. This one's actually a 1/3 horsepower, but a 1/4 horsepower is plenty. Anyway, let me show you how it works. Okay, this is a horizontal boring machine, and it's just like the name implies. It's a drill bit horizontal, and it's for boring a hole in the edge of wood like that. I make these things called gluing dowels. I don't remember how much they are. They're like 3 cents a piece, I think. Pretty cheap. Anyway, they're for holding face frames together on a cabinet, or anything else you want. But, like say that's your face frame on your kitchen cabinets, and you want to glue them together. There's various different methods, and dowel's one of them. Do like that, and you line that line up with the mark on your fence. Do the same on the end. Then, put glue in the holes, put these dowels in, tap them together. A lot of times I'll use a clamp and pull them together. Let it set for about 5 minutes and you won't get it apart. I mean, you'll break the dowels trying to get it apart, but it locks up fast. This machine is designed for 3/4 inch, but you can do thicker wood as well. And I'll show you how. You just make the marks where you want the dowels. Like that. Don't even have to use the clamp on softwood. Flip them over, do the same thing. 2x4 joint. Anyway, that's what we're building today. I believe you can build it for about $50 to $100 depending on what materials you have laying around without the motor. The motor is a 1/4 horsepower. This one is a 1/3 horsepower. I didn't have a 1/4 horse, but 1/4 horsepower is plenty of power. 1750. The only requirement is that it's got a rigid base. If you'll look at this motor, the base is connected to the motor. It's not the isolation mount with the rubber on there. You cannot use those kind of motors. It's got to be a solid mount on the motor. But other than that, you can make about any motor work. Anyway, that's what we're building, so let's get started. Well, there's pretty much everything we need to make this boring machine besides the wood and some hardware and maybe a few pieces of metal for a hold down. This motor is a 1/2 horsepower motor, cheap little motor. It's a 1/2 horsepower 1750 and it's got a solid mount. That's what you need to make this boring machine, a solid mount. If it's got the rubber grommet on there, it will not work. The only machining that will have to be done is this coupler right here. That's a 1/2 inch shaft to a 10 millimeter. So I'm going to build that coupling right now. I looked online to try to find one. It needs to be about 2 inches long, and I could not find one. There will also be plans, linked to some plans for making this, and a parts list, and links to where you can get all these parts. So let's get started on making that coupler. Okay, little change of direction here. This motor here, it's got a really bad vibration and a little bit of play in this bearing here. I don't like it. So I made that coupler off camera. Let's see how this one runs. Oh, much better. This is a gas pump motor. Anyway, let's get on with building this thing. Okay, you could use different kinds of slides. These were incredibly cheap. But the best thing about these is they're supported the full length. If you get the kind with 2 blocks out here and a suspended rail, it'll flex. And the way this thing is going to be made, that flex will be a problem. Okay, let's make our platform 24 inches deep and 16 inches wide, and we'll make the table 16 by 12. That's the length of my slides. If the motor's too low, it's not a problem. If it's too high, that's a big problem. Well, that means we're going to have to elevate the table somehow, or lower the motor. So, I had an idea. Let's make this double thickness. I think it needs to be anyway. That way there won't be any flexing going on. Okay. Yeah, I like it. Next step is to laminate that together, and then we'll go from there. Okay. If you haven't got a nail gun, well, go out and get one. They are super handy. But here's a trick that I figured out for gluing up stuff like this. You get it all lined up just exactly where you want it. Put a couple of nails in it. The nails are not going to hold that. The glue is going to hold it. But now I can put clamps on that and it won't start sliding all over the place. I was really hoping this rail right here and the bearing block would be the same width, but they're not. And what I was going to do is slot this board so that it would get keyed into the wood. But I'm still going to do that. And I'm going to slot both the board that goes on top and this board. so that they'll be in exactly the right place. So what I did is I took the difference between this and this, divided it in two, and over here on the router table I got a spacer. And that will make at least that side of the groove wider to compensate for the bearing block that goes into this half. It'll just make it way easier to construct to have something for that bearing block to key into. This way is not critical, this way is very critical. So, now we got to cut these grooves. And I'll cut one side, cut the other, remove this, and then cut the bottom board. Now I need to remove the spacer and do the bottom board. Now I need to go until this fits in here. And COVID. Really, I breathed in sawdust. It's going to be perfect. It only has to move a little over an inch. Well, it'd be nice if all these were organized. Okay, this is the fence. It'll be on the other side. And I flipped the wood over and cut a real slight groove in the back side. And the only reason for that is so that I can position the templates I made for these blocks. And I'll just line the template up, the holes in the template with the center of this fence, and I'll use screws to hold the fence on that go into here. These two right here are not critical. They need to be at least 2 inches. In other words, I got to have 2 inches of travel here. Really only 1 inch, but we'll make it 2 inches just to be on the safe side. Let's make it 2.5 inch. So now I'm going to use a punch and transfer those holes and then drill them. Now the position this way is really not critical. It needs to be about in the center of the fence right there, but I can make oversized holes and it really won't matter because that block is being contained within the groove. What I'm going to do, I'm going to drill these with like a 3/32 or a 1/16 inch drill and then go to my final size. Let's give the new drill press a try. Now I'm going to drill countersinks. I'm going to use those right there in the top of the table. So well, now we got to set the motor up. As you can see right there, it's just a little bit low. So I'm going to have to raise it up to about there, centered on 3/4. I got a piece of key stock here, which is 3/16, and 3/16 and 3/16 and 3/8 makes 3/4. So that's, I put that 3/16 there. I want that drill to touch the top of the key stock. Of course, I'm too high right now, so I'll try a different piece of wood. I'm actually fairly close right there. I'm a little bit low. I think the best way to do it is probably start out a little bit low and put some washers under it. You could make it adjustable, but it doesn't really need to be. Oh yeah, boy, that's got it. Okay, let's try this thing. Okay. Right there is our scribe line. It's the point of that little drill sticking through there. Okay, need some spacers. A little over 3/4 long. Okay, on a 2-inch dowel, you don't want it more than an 1/8 inch too deep. Otherwise, a bunch of glue sits at the bottom of the dowel and never gets used. So that's where I need to stop it. I think I'm just going to screw a piece of wood there for a stop because it doesn't really need to be adjustable. Okay, I had some blocks of wood that were tall enough to hit that table. If you didn't have wood thick enough, you could cut a 2x4 like that and screw it to it like that. Doesn't need to be complicated, just something simple. Don't even need to measure it. Okay, all I lack is cleaning it up and putting a finish on it. Maybe putting some return springs on it. I don't know about that yet. I'd say it'd probably be a good idea. Let's give it a try. Put a couple of marks across the joint. Line it up with the mark there. Looks good. Pull it together with a clamp. I like it. Sawdust is packing in there behind the, stopping it from going all the way up. Right there is where the wood was building up. The drill shoulder right there was hitting it. Yeah, that'll do it. Well, while I got it apart, I'll clean it up a little bit. Put a coat of clear on it. That'll be for that spring to hook to return the table. There we go. It's got some resistance to it now. It'll stay up. Table spring loaded. We're ready to try it as soon as the paint dries. All I got to do now, I can do this now, is hook up a switch for the motor, power cord and switch. Well, let's give this another try. It's all done. I like it. Well, that about wraps it up. I think it's really going to be a useful machine. I'm pleased with the way it came out. It's a few things I would do different though if I was going to do it over, and I just want to cover those. Let me show you what I mean. The groove I cut in the bottom of the table for the bearing blocks, and the groove that I cut in the mounting board were kind of a pain. The one in the table, absolutely you need them. It's very important that those are perfectly lined up. What I would do on the table, I would just leave those grooves off and put it all together, slide these slides on the bearing blocks and mark the position and screw it down. It's important that you get them positioned accurately, but I believe that'd be easier than trying to machine those grooves in there accurately enough. And I did get this one a little bit off. Those bearings, they're going to be fine, but they bind up a little bit because they're slightly too wide or too narrow. I can't remember which. But that's one thing I'd do different. Remember, the plans will be available underneath the video, a link to the plans. And this groove will not be in the plans. Another thing I want to cover is the type of plywood I used. I just used the local building store had a utility grade project plywood. It's 3/4 inch. It's kind of a weird finish on there. I don't know what it is. Probably some kind of species of wood I don't really know about. But it works good for a project like this. These couplers, I know before I mentioned that I couldn't find a good source for them. So I made up some. This is 5/8 to 10 millimeter, and this is 1/2 inch to 10 millimeter, depending on what motor size you got. I've got a business website that I'm going to put these on, and I'll put a link to these couplers here. I don't know what I'm going to charge for them. I really don't want to get into mass production, but if they sell good, I'll have somebody make them and keep them available. The motor, this is a 1750 third horsepower. 1/4 horsepower is plenty. The 1750 RPM seems to work really well, but a 3450 would probably work even better, and a lot of the commercial ones available are also 3450. I think it would just require a little less pressure to drill the hole, but if you have a 1/4 horse or even a 1/3 horsepower 1750, don't hesitate to use it. Anyway, thanks for joining me, and be sure and subscribe.